The topic for this video is principle of conservation of energy. Let us look at the definition for this principle. Principle of conservation of energy states that energy cannot be created or destroyed, but can only be converted from one form to another. So let us look at one example here. Let us imagine that we have a coconut tree, and here's the coconut. Okay, before the coconut falls, it has gravitational potential energy. Okay, as we know, this is the formula for gravitational potential energy. And from here we know that gravitational potential energy depends on mass of the coconut, gravitational acceleration, and height of coconut. And it doesn't have any kinetic energy before it falls because it doesn't move. And this is the formula for kinetic energy. So formula is half mv squared. M stands for mass of the coconut, and v is the velocity. Before it falls down, velocity is 0, so it doesn't have any kinetic energy before it falls. Now let us look at one example here. Let's say before the coconut falls, the energy, the gravitational potential energy is 100 joule. But there is no kinetic energy because it's not moving. When you sum up the number, then you get 100 joule. So when it falls down, let's say this is the new position of the coconut, you notice that the height has reduced. As you can see here, the amount of heat has reduced. Now the new value for gravitational potential energy of the coconut is 80 joules because it has fallen a little bit. And we can see here when the coconut starts moving, and then the kinetic energy is there. You can see here, for example, 20 joules. But when you sum up the number, then you still get 100 joules. You can see here, the number of 100 here is not changed. This is because it is conserved. Okay, you can see here, it is conserved. That is why the total energy is still the same. Now when it moves further down, now the height has reduced, so gravitational potential energy has also reduced here, but kinetic energy increases because it's moving faster when it's moving down. However, the amount is still the same, 100 joules. Then the same thing happens here. And finally, you can see here when it reaches the ground, just before it reaches the ground, it is 0 joule because the height is 0 for gravitational potential energy. And the kinetic energy is the maximum now. It is 100 joule just before it touches the ground. So you can see here, 100 joules here comes from 100 joule of gravitational potential energy before it starts falling. And the total energy is still 100 joules. So this is what meant by principle of conservation of energy. And then you can see another example here. Let's say we have a pendulum. Okay, let's say we start from here. Before we release it, it doesn't have any kinetic energy because it's not moving yet. And we have gravitational potential energy because it has certain height. For example, here we have 5 joules. Then when you release it, it will be somewhere here. Okay, when it is there, we can say that it has 2.5 joule for gravitational potential energy and plus 2.5 joule for kinetic energy, because the total of energy will be 5 joule also. Now when it is in this position, Now we have no more gravitational potential energy because it is at the bottom, because it doesn't have height. And kinetic energy is maximum now because it is the fastest, 5 joule, and then after that it goes back here. Now the amount of energy is the same as before it is released. So you can see here the amount of total energy is the same, but energy is changed from one form to another.